Abarca, I'm 21 years old. I study mechatronics engineering back in Peru with the Pontifical Catholic University of Peru. I am now the project director of the recently established Mars Society Peru as an official branch of the Mars Society. And I'm here to talk to you about the work we're doing in establishing Mars Analogue Research Station in Pampas de la Joya, which is located in the Atacama Desert in southern Peru. So, just a little bit of where I come from. I was part of Crew 126, or Team Peru, together with Dr. Alejandro Diaz, who is an aerospace engineer from UCLA who works at the bomb company, and together with Andrea Lazarte, who studies environmental engineering, Humberto Las Casas, Saúl Trujillo, and Ian, she studies me, mechatronics engineering. So we are all students, except from Alex, who is already a professional. So we have been hearing throughout all these presentations at the convention that sending people to Mars is the next giant leap for humanity, and all the efforts should be oriented in this purpose. So that's why we want to establish a Mars Analogue Research Station in our country. So Mars-like environments on Earth are important because they provide a better understanding of the geological, geochemical, and microbiological processes that could have occurred on the Red Planet. It's important to perform experimental analysis on the soils that are similar to those that will be found on Mars in order to prepare for future missions. And these soils are also ideal to test the rovers and the unmanned aerial vehicles that could be sent to Mars before its mission to guarantee their success. So the Mars Society has spotted at least 2 of these Mars-like environments where they have built these Analogue research stations. We have Flashline Mars Arctic Research Station, or FMARS, in Canada, and the one I rotated at, Mars Desert Research Station in Utah, USA. So, Mars-like environments on Earth are defined by the distribution of living organisms, by the distribution of organic matter, and the chemical properties of the soil. And it's studied, it's important to find possible habitable environments on Mars. So, a region of great scientific interest, with an analog to Mars of great scientific interest, is the Atacama Desert, which is located in South America, in southern Peru and northern Chile. Now, the Atacama Desert stands as the driest region on Earth. It is a place where rain is virtually absent and where there are no vestiges of life. And its coordinates are those 15 to 30 latitude south, and at elevations between sea level and 3,500 meters above sea level. So, Pampas de la Joya Desert is part of the Atacama Desert. It's the northern continuation of this desert, and is located in the southern part of Peru, right here. So I'm going to show you what's there. So here's a map of Peru. Between the departments of Arequipa and Moquegua is where Pampas de la Joya Desert is. And, but the area of interest is near the city of La Joya, which is located right here in the department of Arequipa in south of Peru. So, why we have chosen Pampas de la Joya? Well, we're basing our research on investigations made by Dr. Valdivia Silva, together with Dr. Christopher McKay, which you see right here, who is part of the Mars Society. And, well, in their work, multidisciplinary approach of the Hippocratic Desert of Pampas de la Joya in southern Peru as a new Mars-like soil analog, they conclude that this zone in Pampas de la Joya is an excellent Mars analog, has excellent Mars analog soils because of the low levels of organic matter in the soil, the absence of microscopic life, the presence of iron oxides, and the landscapes that are similar to various regions on Mars. So these are the exact coordinates of the Papas de la Joya Desert. It's this region A, that was in the image. This is the city of La Joya. And it is surrounded by the Andean foothills. We're here on the letter C, and there are its limits, the Tambo River, Cabana River, Andean foothills, and Cordillera de la Costa. That's what surrounds the area. So there's a specific place in Papas de la Joya Desert called, in Spanish, Mar de Cuarzo, or in English, Sea of Quartz. Its translation. It's an area of 114 kilometers long and 60 kilometers wide, and it's located at an elevation of 1,200 meters above sea level. So this is the area. You can see approximately 1,000 meters above sea level, which corresponds to this rectangular area. And this is where the studies of Dr. Valdivia and Dr. McKay took place specifically. So what show the results? They made studies on different locations in Sea of Quartz, in Papas de la Joya Desert, sorry, and the area of most interest belongs to Sea of Quartz because of these reasons. Sea of Quartz stands as an hyperarid area, which means its aridity index is below 0.05. It has low concentration of organic matter. According to their study, below 20 parts per million of organic carbon, and they compare it to the results of the Viking, which is between 0.7 and 6.5 parts per million of organic carbon. It has high oxygen activity due to the presence of microclimates and the influence of El Niño southern oscillation, which allow the formation of chemical deposits in the soils, such as iron oxides, which give the red color to the soil. It has extreme environmental conditions due to the absence of rain and the low levels of humidity in the soil and in the air. It has low-level microorganisms and Martian-like geomorphological features. These are the exact coordinates of this black triangle that corresponds to the Sea of Quartz. So their study also showed these results of the environmental data. The first chart corresponds to the precipitation, then we have the relative humidity of the soil, the relative humidity of the air, and the air temperature. So we can see that temperature profiles in Mar del Cuarzo, or in Sea of Quartz, are neither extremely hot nor cold. We can see the pattern that's repeating. So the monthly mean temperatures don't vary much year to year. Also, we can see the lack of rain, except for this peak. But in the rest of the season, there was no rain, which was translated in low levels of humidity of the soil, below 30%. And these values of moisture doesn't allow the growth of any type of vegetation since the soil is extremely dry. So, as a conclusion, Sea of Quartz would be an excellent place to establish a Mars Analogue research station for the previously explained reasons, and that's what we're working now in trying to achieve this objective. So. The design of the station will be similar to the existing Mars Society bases, but it will not be exact replica, since we will like to make some innovations, and of what we have heard of the 3D printer, it will also be nice to make some pieces out of it. But our commander, Alejandro Diaz, has important contacts in NASA, and he has told us that it will be a good idea to collaborate with NASA's Deep Space Habitat and Habitat Demonstration Unit that have current designs of bases that are active in NASA's project. Sorry. So, but it will be similar to the Mars Society bases in the meaning that we will have 2 floors. On the first floor, it will be the working zone, so we will be needed to be equipped with the necessary tools for investigation. I mean, mechanical tools, electronic components, refrigerator for samples, biological and geological tools. And the second floor will hold it will be the place where the researchers will sleep. And it will have also the refrigerator, the food pantries, and the kitchen, and also a work zone for the researchers to write their reports. So the simulation in La Jolla will last for 2 weeks each crew. It will hold a number of researchers of 6, and they will work under strict simulation protocols, meaning that they cannot go outside without using their simulated spaces, that they can only go outside for research purposes, and that they have to write reports daily to mission supports, as we did when we were at NDRS. Currently, the Mars Society of Peru is working with my university, the Pontifical Catholic University of Peru, in a simulated spacesuit project that will have innovating characteristics such as control and monitoring of a rover and a UAV with voice commands, and we're currently working on it. So
what's that thing on the left there?
That's Google Glass. We're planning to use that technology in the suit. So we will conform the team of mission support together with other participants of the Mars Analogue Research Station programs to guide the crews that will be in the Jolla station. And to make the simulation more real, we will limit the resources such as water, food, internet, and fuel for the ATVs. So space and weight are critical designs are critical parameters in the design of a spaceship. So a spaceship won't be able to carry tons of food and water all the way to Mars. So it's important for the research, for the Mars explorers to build and maintain their own green hub. That's why the station in La Jolla also needs to have a green hub as well. They will cultivate a variety of plants, in which we want to include the Peruvian quinoa, which has a high nutritional value since it contains a lot of proteins and has already been used by NASA. So these values, these numbers we see over here were given to us by the Mars Societies, the approximate cost of the Mars Analogue Research Station in Utah. So we believe that the cost of the station in La Jolla will be similar, a total of $230,000. We're still looking for funding for this project, but so far our university has shown strong interest in funding part of the project, but we still need major financiers. CONIDA, which is the Peruvian Space Agency, has shown, we have explained our project to them. They have shown strong interest, and they will provide with technical support in the areas of astronomy, physics, and biology. And the area of Pampas de la Jolla is located near a military base of Peru that belongs to the Peruvian Air Force, of PAC. We have also had reunions with the General Secretary of this organization, and just before we came, we had an important reunion, and we were about to sign a mutual agreement to use the area that belongs to them in La Jolla. When we return to Peru, we will continue these meetings with this organization, and we are planning to take a trip with Dr. Valdivia, who's currently in Peru, to La Jolla station in order to establish the exact location of where this will be. So this project is very attached to the organization of the Peruvian Air Force, since it's their territory. The military base of PAP has an airport, which we will be able to use for the transportation of the crews between our capital city, Lima, and La Joya in Arequipa. And they will also provide military security for the station, which is important to guarantee the safety of the crew members and of the station itself. Plus, they have, this is their complex. They have one of these buildings is a hospital, which we will be able to use in case of any emergency, and they will provide medical staff. And we will also be able to use one of the buildings for the crews to stay the nights before and after the rotation. So that's all we have for now. Feel free to contact me if you have or if you need any more information. And if you have any questions, I can answer them.
Yeah, I do have a question. So, I don't know what percentage of research on Mars is put out by which countries, but I imagine the U.S. puts out quite a lot. And so, of course, for U.S. researchers, going to Utah would be very convenient, much less expensive. So, which researchers do you anticipate utilizing your station primarily? Are you seeing it as like locally based researchers, or are you seeing it sort of as like people who might actually find it considerably less expensive to go to Utah but can't get time there, would then go to Peru, or how would that work out?
I think I didn't mention it. That was my mistake. This station needs to be international. Definitely not only Peruvians will go there. We want us, NDRS and if Mars receive researchers from all around the world, we also want to do that. So it will be, I mean, maybe only the first crew will need maybe to be us in order to like test the things and that, but we want the station to be international.
So how do you intend to compete with more accessible stations financially?
Well, what do you mean competing?
I'm just curious. I'd be interested in knowing who primarily would go there. Do you think it'll be like researchers from Utah are likely to go to Peru, or are you looking more like European researchers, or It seems like this would be the second one in the world, right?
Well, in the desert, yeah. In general, the third.
The third.
Yeah.
So I don't know who primarily goes to that whole.
Well, the researchers that want to do research related to Mars are welcome. This place is a great analog to Mars because of the studies that have been made by the researchers I mentioned to you. So we are able to, or we will be able to receive researchers from all around the world.
There are a lot of worldwide Mars analog sites.
Right.
The fact that there's only less than a half dozen stations doesn't mean that there's not, a worldwide collaboration in terms of research that's being done. I don't think it would be competition at all. I mean, I think it's quite exciting. My question is going to be, if you don't get the money for the station, will you go the same route as the Australians and hold expeditions before you have a station?
But the Australians, where do they go?
They have a site. They just haven't been able to build their habitat yet.
Okay.
And so we've had, 5 different expeditions to their Mars analog without having to have built.
They go to the site and camp?
Yeah, and well, it turns out that the site is very close to an eco resort, and so they lend us their sheep station and we stay there. So you have the opportunity with the military building to host expeditions where you wouldn't be leaving people out. And I would encourage you to consider that route while you're getting funding for the station. Think about holding an expedition where you invite some of the leading Mars researchers to your station, even before it's a station. Then when it becomes a station, everybody will want to go. It will be the cool place.
We actually didn't think about it, but it's a really good idea. So
So the Australians decided they weren't going to build a hab unless they could build one, a very expensive, very high fidelity hab, and they've never got funding for it. So we continue to hold Mars Analog expeditions on site, and they're very successful. So I would encourage you to consider that while you're waiting for funding for your.
Thanks for 5 more questions or 5 more minutes?
You have 9 minutes.
Oh, okay.
Are you dealing with extremes of heat or cold at your site?
Well, as I showed, the temperature profiles, they're not really that cold. The least was 4.5 degrees Celsius. Let me show you that.
So, I mean, like, is your crew member gonna die if the cooling or heating system fails, or is it, well, they have the military bases, so.
Well, there is the military.
Oh, there
so
we
this
are,
is-
yeah,
This is from the
So
mountains
the
to-
heat looks like the dangerous.
Exactly. From January to April, we have summer in Peru, in all of the country.
Right.
So those are where the most high temperatures are. So maybe there, in that season, we will
Looks
have
like more of
cruise.
a heat danger.
Exactly.
Right,
So
more
maybe in the summer,
Yeah,
it
22
will be
degrees
time
C.
for refit,
Uh-huh.
stay to here at MDRS, but not for the cruise to stay. Yeah.
Yeah, I noticed you said that NASA had been using some quinoa. I've been cooking with quinoa, and I wouldn't really want it in a zero-G environment. It's kind of powdery and gets everywhere. How has NASA been using quinoa, and how will you use it and keep it out of your
Well,
systems?
I've talked to Dr. Diaz, and he's the one who told me that NASA, well, he has a strong relationship with NASA since he works with the wine company. So he's the one who told me that not only the Peruvian, but the quinoa from Bolivia, because we're the top producers of quinoa in the world, they have been sending quinoa to NASA to test it in order to see if it will be usable in the International Space Station. And I don't know the research of that. I don't know if it has already been in the International Space Station, but I know that they have been experimenting, or at least testing the consequences of eating quinoa.
Can we find out if it finishes? I guess I have one more question. How much drier is the Atacama than, say, Utah? I noticed the precipitation graph only really spikes in
so
2006.
In
Yeah.
the study listed from 2004 to 2008, in 4 years, they only had 7 rains. These are because we have a phenomenon in South America called El Niño Southern Oscillation that produces that causes the rain in the coast of South America. So that's why this peak of, the rain happened in that period.
Once in a great while it will rain.
It's the El Niño Southern Oscillation is really random, so scientists can't predict where it's gonna come or not. Hopefully, not in many years.
So you would not occupy the hab during the real high temperatures? You just wouldn't be there?
Maybe it will not be Spanish. It would be a good idea to do that.
During the summer here, they don't occupy MDRS.
Well, we don't have much high temperatures as here. The maximum recorded was 35, but we see the mean temperatures that they reach 22
That's like 70
degrees.
degrees.
So but it's the mean temperature. So one day it could be like 35, and the other day it could be less. So we don't know. It won't be a good idea to put crews in the hab in the summertime. But if you're done with it, are there any more?
Just a comment, looks like a very well thought out plan. All you need is money. It's so easy, all you need is money.
Me too.
That's the easy part. Thank you very much for
Thank you.